Good morning, everyone. Today we are going to cover topic 5.4, the human alimentary canal, and this is part 2. We're still going to stick with the same learning objective like last time, and we are going to relate the parts of the digestive system according to the stages. And today we are going to focus mainly on the duodenum and a bit on the pancreas. And maybe I'm going to touch a little bit on the gallbladder, just a little bit, but not specifically there yet. Okay. So this is still the stages of the human nutrition. And let's do a bit of a recap from what we learned last session. There are 5 basic stages of human nutrition, and we have ingestion, digestion, absorption, assimilation, and egestion. Alright, so starting with ingestion, this is when you take in food, and this is eating. And digestion, you have 2 parts, which is mechanical and chemical. Let me just get the laser pointer out, okay? Is that alright? No, it's a little bit slow. Let's get it out. Alright. So, digestion is divided into 2 types. Mechanical is when you kind of cut the food physically to become much more smaller in size. So this helps to increase the surface area for enzymes to work on it. And you have chemical digestion, which is actually chemically breaking it down. So you're breaking the bonds of that molecule. Whereas for mechanical, just kind of cutting it into smaller pieces, but the molecule itself, like the structure, is generally still big. But chemical digestion involves actually going into those bonds and actually breaking those bonds. This is just like taking the shape, like changing the shape. That's why it's called mechanical. Absorption is when you take the food substances and you put it into the bloodstream. So you know that the blood is used to circulate around your body, and it transports materials. And some of the materials that your blood transports is actually nutrients that they get from the digestive system. Assimilation, I changed the definition here to incorporation of absorbed chemicals into the structure of the organism. So assimilation just means that you're going to use up those nutrients and you're going to kind of make it a part of your body instead of like using it. Like for example, breaking it down to energy. Assimilation is more like you take that nutrient and then you make it into something big. So like glucose is converted into glycogen, which is going to be a part of your body. Glycogen is a storage form of sugar, and this is what we are using right now while we're fasting. So it gives us energy even though we're not eating. Egestion is when food is passing out of the human alimentary canal. So this food that is passed out, those are the things that we cannot digest, and the food that we don't absorb in our body. Sometimes our body doesn't need it because we have enough of it, so we also remove that. But most of the time, this is the type of food that you cannot digest because you don't have the enzymes for it. So for example, fiber, we don't have enzymes for breaking down cellulose, so it provides bulk and it helps to kind of like push the food down the digestive tract. We look into the function of the mouth, the esophagus, and the stomach. So let's do a recap of that. So the mouth is involved in 2 stages, which is ingestion and digestion. Ingestion is when food enters the digestive system. So this is the start of the human digestive system. And you have the digestion part, and this is actually 2 as well. So your mouth does quite a lot. You don't just talk, but you also are able to digest and ingest. And digestion mechanically and chemically as well. Mechanically, the teeth actually cuts the food into smaller pieces, so physically only, physical change, and you have the chemical change, which is using salivary glands. The salivary glands secrete amylase, which is an enzyme, and this enzyme acts on starch. So in your mouth, the first process is actually starch being broken down into maltose. In the esophagus, digestion still occurs, but this is not because the esophagus releases any enzymes, but because the enzyme from the mouth and the saliva is in the bolus of the food. So amylase is still being broken down. Like once the bolus comes down here, there's still enzyme action there. And also the process called peristalsis, which is the movement of the bolus down the digestive tract, so down the esophagus into the stomach. The stomach has a few different types of processes going on. So let's talk about digestion first. So we have protease enzyme. So just so you know, the stomach secretes a juice, which is this one right here called gastric juice. And this gastric juice contains mainly these three main stuff here. You have the protease enzyme, and protease acts on protein, and the protease enzyme is specifically called pepsin. So pepsin acts on big protein molecules and converts it, actually breaks it down into smaller, shorter polypeptide chains. And we have renin, but only for children and like babies. And this renin is also an enzyme and it helps to clot protein inside milk. And you have HCl, hydrochloric acid, that your stomach actually secretes, and this is really important because it helps to kill bacteria. And also it lowers the pH because pepsin works at low pH environment. There's also peristalsis going on in here because the stomach is a big muscular wall actually, so it also pushes the food, which is now in the form of chyme. Actually, it's not chyme, it's actually pronounced as chyme, so K. So chyme. So this bolus, once it interacts with the gastric juice, it kind of becomes a bit more liquidy, so semi-solid, and you call that chyme. So the stomach also churns the bolus into chyme. So churning means that it's going to kind of like contract and kind of mix. Yeah, it really mixes the bolus into the gastric juice. So I need to kind of explain this curdling of the milk. So milk has this protein called casinogen, and it is actually soluble in water. So that's why you see milk as a liquid, but it can turn insoluble. And so that's when it becomes pretty much solid and it cannot dissolve anymore in the liquid part of milk. So renin is the enzyme that clots, or the word coagulate or curdle, milk protein. And this milk protein, remember, is called casinogen. Renin does this by speeding up the conversion of soluble casinogen into insoluble casein. So casinogen is much more smaller and they're apart, so they're very easily to become soluble and dissolve in water. And the enzyme renin, what it does is that it speeds up these guys to kind of like come together. So we call that clotting, coagulating, or curdled. So you can see that it becomes a bigger molecule here. And that's what happens over here. So this is what you call now casein when it's insoluble milk protein. So the good thing for having this is the fact that it's insoluble. So it'll be kind of much more tougher for the enzymes to break it down. So the enzymes will take its time, and that means that you're going to have like a constant supply of protein in the body. So if it stays longer inside here, then you don't need to kind of like eat a lot of times. So babies, for example, they can't go to the fridge like we do and get some food. They rely on milk, and that milk can be kind of stored in their body first, so the milk protein. So they're going to digest it slowly, so they still have energy throughout the day. But you have to feed the baby quite a lot of times though. Okay, now we're going to look into duodenum. Actually, I didn't get to cover a lot of these, so we're actually just going to cover duodenum today, a bit of pancreas, not these guys. Okay, so in the duodenum, it is actually, duodenum is a part of the small intestine. So it's the first part of the small intestine, and it is a U-shaped tube, so it's right here. I call it a C shape actually, but they call it U shape. And it receives three types of digestive juices. So you can see here we have the stomach, and you have the liver here. You have the pancreas right here, and the gallbladder. So they're all actually, the liver is not directly in contact to the duodenum, but it has this gallbladder that's attached to it. So this gallbladder attached to the liver is connected to this part right here, which is the duodenum. So once the chyme enters the duodenum, which is the first part of the small intestine, what happens is that over there you have digestive juices being released. So the first thing is bile. So bile is the first digestive juice, and this is via the bile duct. So over here you can see the gallbladder. Gallbladder actually stores bile. The liver makes the bile, stores it in the gallbladder, and then this bile will actually come down here. So that tube right there, that's called the duct, so the bile duct. That's where bile is released here. So this bile will emulsify fats found in the chyme. And the second digestive juice is the pancreatic juice, and it comes from the pancreas. If you guys can see right here, this is what a real digestive system looks like. So that's the stomach. I think it's like cut as well. And then you can see right there, that's the duodenum, and the pancreas is actually attached to the duodenum. Okay, so let's go back to pancreatic juice. So pancreatic juice is made in the pancreas and is actually released via the pancreatic duct. So a duct is like a small tube and it releases substances. So the pancreatic juice can contain enzymes. There are 3 enzymes that the pancreatic juice contains, which is amylase, protease, and lipase. And you have the hormone as well, which is insulin. Another digestive juice, the third one, is called intestinal juice. So intestinal juice is the digestive juice that the duodenum itself makes. So the walls of the duodenum makes this, and it contains much more enzymes. It also contains lipase. There's this enzyme called erepsin, which is a protease. You have maltase, you have sucrase or invertase, and you have lactase. Okay, so the function of the bile. So bile over here, you can see that it's a green, yellow colored fluid. So this is actually a product of the breakdown of old red blood cells. So your red blood cells, they are created from your body, but then they have a short lifespan. So once the red blood cells are being used up and they're worn already, they're going to be broken down inside the liver, and this is what you actually get. So this bile is stored in the gallbladder, and it contains this thing called bile salt. Bile salt emulsifies the fat, so it converts large fat molecules into smaller droplets. So let's see how that actually works. So emulsification of fat globules. So fat, they actually come in like this big group. So what the bile salts do, so this is a bile salt. You can see that it has here, it says hydrophobic and hydrophilic. Fat is insoluble in water, and what bile salt does is that it kind of helps it a bit more soluble as well as breaking it down into smaller pieces, smaller physical pieces. So if hydrophobic means that they are afraid of water, and hydrophilic means they love water. So hydrophilic parts will help it to become dissolved in water. And what you can see here is that the bile salt, the hydrophobic part, is going to be the one attached to the fat. So once it surrounds it, you can see that only the hydrophilic part is out here. That means that it's going to be able to dissolve in water. So there is larger surface area that allows lipase to chemically break down the lipid into glycerol and fatty acids even more faster. So this helps to digest the fat faster. Fat digestion still occurs even without bile, but it will take a much longer time. So this is very large, you can see, and the bile, it kind of separates these globules into smaller pieces. And this one, you can see that over here you have this one surface area only for enzyme to work on, but now you have 1, 2, 3 separate surface areas. So that's what we mean by surface area being increased. Alright, so the pancreas is this thing right here, and we draw it kind of like a leaf shape because you can see that it doesn't really look like a leaf here, but you can see kind of the leafy shape over there. So to simplify, we draw it like that. The pancreas can be found in between the stomach, so here, in between the stomach and the duodenum. And this is actually an organ, and it secretes pancreatic juice. It is part of the digestive tract, but it's not in the human alimentary canal, so we call it an accessory organ. Just like gallbladder as well as an accessory organ, like liver too, because it's not like the tube. It's not a part of that long tube. So once the chyme enters the duodenum, so pancreas will then secrete the pancreatic juice. Just right there, that's called the pancreatic duct. That's where the pancreatic juice will be released. And this helps in the digestion of starch, fat, and protein. Pancreatic juice actually contains amylase. The substrate here is starch. Substrate means the substance that the enzyme will work on. So it's going to work on starch and converting it into maltose. And the product here is maltose. And that's 2 small glucose molecules chemically combined together. The second enzyme that can be found in the pancreatic juice is trypsin. Trypsin sounds like pepsin, and they're both actually protease. And this trypsin acts on protein, and it has a similar function to pepsin. So it actually breaks down the protein into short polypeptide chains. And the third enzyme that can be found in the pancreatic juice is lipase, and the substrate is fat. So it actually breaks down fat into fatty acids plus glycerol. So mechanical digestion of fat, as we talked about, chyme enters the duodenum, but at the same time as pancreatic juice is released, you have bile release from the gallbladder. Bile will neutralize the hydrochloric acid that's found in the chyme from the stomach. And at the same time, bile salts will emulsify the fat to break it down from large fat globules to smaller fat droplets. So something big will turn into like smaller pieces, just like that. Alright, so because the animation is a bit wonky, now I think we got pretty much everything. Alright. So last part of today, I'm going to explain to you about how we digest fat. So the pancreas releases pancreatic juice, and that contains the enzyme lipase. So this is now going to be active because of the basic environment. Basic, I'm referring to the base as in the pH. Because of the bile, it creates a higher pH, so that becomes more alkaline, and enzymes like lipase work best in alkaline environment. So lipase will now act on the emulsified fat droplets and breaks down the bond within the fat molecule to form fatty acids and glycerol. So you can see this is one fat droplet, but in each one of these, like that one unit there, this is how fat actually looks like. It's made up of glycerol. Okay, let me just change that a little bit. So glycerol is only that part right there, the green part. That's one glycerol molecule there, and one glycerol molecule is attached to 3 fatty acids molecule. This exact shape. That's 1 fatty acid, 2, and 3 fatty acid. So this is 1 unit of a fat molecule. The enzyme lipase, what it does is that it breaks down these guys right here into smaller pieces, which is it separates the glycerol from the fatty acids. Alright, so that's it for today. Thank you so much and have a good day, guys.